So today we're going to talk about section 6, which is the last section of our chemical composition unit. We're going to talk about how to calculate molecular formulas. So we've already talked a little bit about the difference between empirical and molecular formulas. So let's just review. If you remember, empirical formula is the simplest whole number ratio of how the elements are put together. So an example that we did in the last section was that the empirical formula was CH2O. Okay, then we talked about molecular formula, which is the actual whole number ratio. Sometimes it is the same as empirical, such as in water, and sometimes it's different, or it's a larger number of atoms, but the same ratio. And so an example of molecular formula would be C6H12O6. The ratio for both of these is still 1 to 2 to 1, except now we've multiplied this ratio through by 6. So we're going to talk about how to calculate molecular formula. Okay, well, in order to calculate molecular formula, you need two things. The first is the molar mass of the molecular formula, and this has to be experimentally determined. So it would have to be given to you in a problem, or you would be experimentally determining it yourself. The second thing we need is the empirical formula, because the molecular formula is an integer multiple of the empirical formula. All that means is we take the empirical formula and multiply all the subscripts through by some number to get our molecular formula. So we need to figure out what that number is. How are we relating empirical to molecular formula? Well, the way that we do that is it's empirical formula times some number is equal to the molecular formula. So for example, CH2O times 6 gave us C6H12O6. So the way that we're going to find that number, let's go back for a second. Okay, that number that relates empirical to molecular formula is equal to the ratio between molecular formula and empirical formula molar masses. So we said that this was given in the problem. It's experimentally determined. And this you have to find from the empirical formula. And so sometimes the empirical formula will be given. Sometimes first what you have to do is find the empirical formula, and then using that, find the molar mass to get the molecular formula. Okay, so sometimes it's more than a one-step problem. Since we've already talked about how to find empirical formula, we're going to assume that you are good on how to do that, and we're just going to talk about how to find molecular formula. So remember, we need to find that number that relates empirical formula and molecular formula to each other, and that's by taking the ratio of the molar masses. Well, we already know that the molar mass of the molecular formula is our 283.88 because that has to be experimentally determined, and so it has to be given to you in the problem. Empirical formula molar mass we need to find. So for our empirical formula of P2O5, we're going to take 2 times phosphorus's atomic mass, which is 30.97, plus 5 times oxygen's atomic mass, which is 16. And if I calculate that out, I get 141.94 grams per mole. And so now I'm going to get my ratio, or my number. So I'm going to take my molecular formula molar mass divided by my empirical formula molar mass. And if I divide those two out, I end up with 1.999, which is really close to 2. And so that means I can take my P2O5 and multiply those subscripts through by 2, giving me P4O10 as my final answer. Okay, so once you have determined the empirical formula, it's this simple ratio of the molar masses to get molecular formula. Okay, so try this example on your own. We have an empirical formula of ClCH2. Oops, that should be a small 2, so let me write it out for you. So we should have ClCH2. Okay, and a molar mass, an experimentally determined molar mass, of 98.96 grams per mole. And we want to find the molecular formula. Okay, so remember that you need to find the molar mass of the empirical formula and then divide those two molecular masses in order to get the ratio. Okay, so go ahead and pause the video, try this example. If you're not sure, go back to the previous example because it's very similar. But when you're done, you should get this as your answer. Okay, so make sure you try this and we'll discuss it in class. Have a good day.